Hello everyone, welcome back. Now we explained that those scattering and we solved some example regarding to XRD, but we have the crystal structure. Now there are other information that we need to know in order to be able to fully analyze XRD pattern. Now the Bragg's law that we have it, it's give us indication that some planes, we have equivalent plane and it will give us peak. Now not all of the planes within the crystal structure will be spotted by will follow the Bragg's law, or they will not be seen by the Bragg's law. Now why? Because the machine, it's only collect the scattered angle from here. Some of them will scatter somewhere there, so they will not be able to gather all of the planes. So there is some rules that we will know that which of the crystal structure that we having there. If you know the rules, when we're collecting those angles, those scattered waves, we know that because of their behavior, we know that which plane will be scattered in FCC, which plane will be scattered in BCC, and which plane will be scattered in simple cubic. Because we have different atom arrangement, yes? Now we explained this one in the beginning when we said that the atom arrangement, that's basically each plane we have it, yes? Now if I check, this is a plane, this is a plane. Where is the equivalent plane? It's somewhere here. The equivalent plane will be there. The another equivalent plane basically will be somewhere here. This is another equivalent plane. Well, I can draw different plane, yes, different plane I can draw them. So which of those plane basically will be seen in the XRD for BCC crystal structure, for FCC crystal structure, and for simple cubic crystal structure? We're going to cover only 3 of them. So which of the planes will be scattered, will be seen by the machine? We have to know some knowledge on them in order to use this knowledge to spot the crystal structure. Or if we know the crystal structure, we'll be able to spot the planes, which one will be. Now, what will be the rule that we're following them? Now we need those rules in order to be able to do this analysis. Now, it's written here that for a BCC crystal structure, the peaks that you see them on the plane, on the pattern, or in order to have a diffraction, the peaks to be shown, the H plus K plus L must be even number. H plus K plus L, the Miller indices, must be even. Now what does that mean? If we have a BCC crystal structure, a plane, let's just choose a plane 1 1 1. Plane 1 1 1, is it going to be spotted by the XRD in the pattern? Let's check the rule. It says that the diffraction will occur if H plus K plus L is even. I mean, it will be spotted by the machine. Well, let's say that 1 plus 1 plus 1 became 3. I mean, the summation of them, H plus K plus L, will be 3. Well, it's not even, yes? So you mean that this plane, we have a plane 110 in BCC, but it cannot be spotted in an XRD pattern. So the plane that we're going to see them will be those plane where H plus K plus L is even number. Now look at this one. 1 plus 1 plus 0 is 2. So this will be shown, but this one cannot be seen from the pattern. So it says that if the summation of the plane is even number, it can be seen. Look, for example, here we have another one. Here's 200. 2 0 zeros, okay, yes, because 2 plus 0 plus 2 is 2. 2 plus 0 plus 0 is 2. It's an even number. Also, this can be seen within the pattern. So what does it mean? What does it mean? If you have a pattern here, look at here. Look at those plane. This is a BCC crystal structure. It's a BCC crystal structure. 1 plus 1 plus 0, it's 2. 2 plus 0 plus 0, it's 2. 2 plus 1 plus 1, it's 4. The summation of HKL, it's even number. Summation of HKL, even number. Summation HKL, even number. The even numbers are what? 2, 4, 6, 8. I mean, it has to come one of those. 2, 4, 6, 8, 10. Summation of the HKL must be even number. This is a rule that we're going to use it, that we know that this crystal structure, look, I'm just knowing this knowledge, I know that this crystal structure is BCC. It's nothing written, nowhere is written here, yes, it's nowhere written. Just by knowing this knowledge, 1 plus 1 plus 0, that's going to be 2, 2 is even. 2 plus 0 plus 0, for example, this is even. 2 plus 1 plus 1, it's even. So I know that this, all of the peaks even, indication of BCC crystal structure. Well, what about FCC? For FCC crystal structure, don't worry, we'll explain more examples for these rules. For FCC crystal structure, it says that HKL individually, each of them, not their summation. Remember here we don't have summation. For FCC, individually, each of them, all be either odd or even. So all of them, I mean HKL, if all of them odd or all of them even numbers, then this is an indication of FCC crystal structure. An indication of FCC crystal structure. Let me just show you a case. Now let's say we have some peaks here. Now if this is 1, 1, 1, this is 2, 0, 0. Now this is 2, 2, 0. Let's see how we have another peak. Let's see, we have another peak here. Now let's say this peak is 3, 1, 1. Now what are the relation between those Miller indices for each plane? If you look at them, if I sum those, 1 plus 1 plus 1 will be 3. This is odd, yes. Some this will be even. Some of this one is even. Some of this one, 3 plus 1 plus 1, that's going to be 5. I mean, not all of them even, yes. But if you check the Miller indices, 1, 1, 1, 3 of them, I mean 3 of them are what? 1, 1, 1, 3 of them are odd, and all of them are odd. Here, 2, 0, 0, 2, 0, 0, all of them even number. 2, 2, 0, all of them even number. 3, 1, 1, all of them odd number. This is a rule that for FCC crystal structure, or the plane for FCC, in order to be diffracted, to be spotted by the machine, the HKL, all of them will be even, or all of them will be odd number. Odd number, even number. 2 is even, 0 is even, 3 is odd, 1 is odd. So all of them odd, all of them even. This is an indication of FCC crystal structure. An FCC crystal structure. Will be much clearer when we solve it. For simple cubic, all the combination will happen. For simple cubic, all combination. I mean any combination. There is no rule. Any combination. I couldn't write it. Any combination. For simple cubic, any combination. Any combination for simple cubic will be seen scattered, and all the planes will be scattered in the simple cubic. Why? Because simple cubic only has 4 atoms at the corners. 4 atoms at the corner. I mean, the planes that we have them basically, they will have something relation with the corners. That's what will be scattered. Now, let's say how we're going to use this information to know which, let's say that we have a, let's go for this example to show it to you. Let's say I have a graph. I have a graph. How do I know which peak is the first one, the second one which peak, the third one is which peak, the fourth one is which peak? Now this is, let's say 325. Yes, let's say if it's FCC, they tell us this FCC crystal structure. Now if I know FCC, how do I know the first peak, the second peak, the third peak, the fourth peak? I know the rule for FCC. It says that HKL either to be odd or to be even. All of them to be odd or even. So how do I know what is the plane here? What are the planes? This one, this. Now let's explain this one in more detail. We need some other information. Now we will use, first we'll start with the BCC crystal structure. Now we're using two rules. First one, we know that in BCC crystal structure, H plus K plus L will be equal to even. Now what does even numbers we have them? We have 2, 4, 6, 8, 10, 12, 14, and so on. I mean, those are the even numbers. Yes, those are the even numbers. Now, a combination of HKL, their summation, can give us those numbers. Now, there is another. We're gonna call those number, we call H square plus K square plus L square. We're gonna have this one, those value, I mean their square. We're gonna find set of plane that their square will be 2, and again H plus K plus L will be even number. Now let's find some planes that will follow these two rules. Their summation will be even, doesn't matter what will be the even, but their square will be 2, 4, 6, 8, 10, 12. Those are basically from the, will be the kind of magnitude of the plane we have it there. Now let's see what we need to know on this one. Let's say we're going to have a plane. We're going to create a plane here, that the H plus K plus L will be even number. The even is not equal to 2. But their square will be equal to 2. Now let me start with 1. I'll put 1 here. 1 square, it's 1. Yes, still need 1 more. If I put another 1 here, now 1 square plus 1 square became 2. So I don't need anything else. I can put 0 here. Now 110. Does it apply to two rules? One rule is here. One rule is here. That's supposed to give us 2. Does it apply? Let's check the first rule. H plus K plus L will be even. 1 plus 1 plus 0, it's 2. 2 is even number. That's perfect. So this is, for the first rule is okay. For the second rule, Is the square of those 3 equal to 2? 1 square plus 1 square plus 0 square will be 2. So this is the first plane that will be scattered in a low angle. In a low angle will be scattered in the XRD. Can we find something else will have the 2 rule? Well, somebody may say that 0, 1, 1. Isn't it? It's the same thing. Yes, 0, 1, 1. It's also possible. Why? Because 0 plus 1 plus 1, it's even, still 2. And again, we'll give you the same. And even the rest is minus 1, 0, 1. Remember, those we call them what? Family. So the family, basically, that their square is equal to 2, all of them will be for the first category. So we can say a family of, this family like this, this family like this, family of 1, 1, 0, all of them, they will be seen firstly. All of those planes will be seen firstly. Why? Because their summation even and their square will be 2. Now let's go for number 4. Number 4. We're going to try to have a combination again. Now if I go 1, 1, 1, 1, 1, 1. Now this 1, 1, 1, their summation will be 3. 3 is not even, so this is not a possible condition. If I go for 2, I'll start with 2. 2 square became 4, yes. I have this 4 here. Now if I put 0 here, another 0 here, what happened? 2 plus 0 plus 0, 2. 2 is even number. Remember, do not compare the even with this one. 2 plus 0 plus 0, it's even number. It's even number. Then 2 square plus 0 square plus 0 square is 4. So this is also the second family, which we call them family of 2, 0, 0. Family of 2, 0, 0. Then we'll continue for 6. We will try to get 6 out of the combination. Their square will be 6. Their summation will be even. Now if I put 3, it will be more. Yes, 3 square will be 9. So I'm not going to go for 3. I'll go for 2. 2 square is going to give me 4. If I put 1, 1 square is 1, 5. Another 1, I'm getting 6. Yes, 2 square plus 1 square plus 1 square became 6. Well, is their summation will be even? 2 plus 1, 3 plus 1, 4. 4 is even number. 4 is even number. So it's possible to have this plane. This is the third plane. So if someone says that we have a BCC crystal structure, we know that the first plane is 1, 1, 0, the second one 2, 0, 0, the third one is 2, 1, 1, and we continue in this manner. For 8, how can I get 8 here? If I go for 2, 2, 0, 2 square is 4, 2 square is 4, 4 and 4 will be 8. 8's 2 plus 0, it's 4, 4 is even number, 4 is even number. Remember please, their summation, do not compare it with here. This is their square, not their summation. Some students say, sir, this summation is 4, it's supposed to be written here. No, those are considered as their square, their summation just to be even number, That's why I wrote them the even numbers here, but those even number not for the summation, it's for the square. Now for 10, how can I get 10? If I give for 3, 3 square became 9, yes. Then I need 1, I'll put the 0 here. Is 3 plus 1 plus 0 even? Yes. 3 plus 1 plus 0 became 4. 4 is even number. Their square, 3 square 9, 1 square 1 will be 10. And so on. You will be able to find all the planes that we have there. So if I go for 12, I'll go for 2, 2, 2. 2, 2, 2. That's going to give me 12. For 14, if I can go for 3 is 9. If I put 2, what will happen? Became 13, yes. So this is 4 square. Sorry, 2 square will be 4. 3 square will be 9. 9 and 4, 13. I'll put 1. That became 14. Is there the summation even? 1 plus 2, 3. 3 plus 3 is 6. 6 is even number. 2 plus 2 plus 2 is 6. 6 is even number. 1 plus 4 plus 0 is 4. 4 is even number. Look, two rule with checking them. Check all of these plane. Their summation will be even number. Their square will be 2. Their square will be 4. Their square will be 6. Their square will be 8, and go on in this manner. Let's say I'm checking 22. How can we find those things? I need you to practice by yourself to put a number, an even number here, an even number here, and try to find the plane by yourself. Now for 22, if I put 4 here, the closest square is 16, yes? Because if I put 5, will be 25. I'll go more than. So I'm putting 4. 4 square became 16. I have 8 more, yes? Well, 8 more I can put 2, isn't it? 4 square 16, 2 square 4, 2 square 4, 4 and 4, 8 with 16 became 22. Or became 24, this one. 16. No, sorry, we have 2, not 2, 2, 2. Not 2, 2, 2. 4 became 16. So I have 6 remain. 6 remain there. For 22, will be 6. Now let's see that what will happen if I put 6 here. Can we get 6 out of those two? I thought it's 24. My mistake. So if I put 2, I cannot put 3, yes? If I put 3, 3 will be 9. 9 and 16 will be more than 22. So if I put 2, we said that 2, if I put 2 will be 24. It will be 24, yes? So it means that it will not get a combination with 4. I'm trying something else. Let's see if I put 3, 3, that's 2 together, how much it will be? 3, 3, 3 will be 9, 9 and 9, 18. Now 18 with 20 to 4 remain, I can put 2 here, 2 here, isn't it? 3 square 9, 3 square 9, 2 square 4, 9 and 9, 18, with 4 became 22. This is okay. But is their summation will be even? 3 plus 3, 6, plus 2, 8. 8 is even number. It means that this plane is okay. So we're checking in this manner to know the plane for BCC. Now I don't want you to memorize those plane 110, 200, 211, 220. No. Know this one. Know this one. Know this information. Then you'll be able to know which one will come. This is the first peak. This is the first peak. And this is the first peak. This is the second peak. Third peak. The fourth one, and so on. So we know the first peak will be 110, the second peak will be 200, third one, fourth, fifth, and so on. Now let's see. Here's the top. Look at here, the first plane 110, which basically h square plus k square plus l square is equal to 2 here, 4 here, 6 here. Remember, the easiest way is to check their square, and the first rule, 1 plus 1 plus 0, it's even. 2 plus 0 plus 0, it's even. 2 plus 1 plus 1, it's even. So all of them even, and their square. 1 square plus 1 square is 2. 2 square will be 4. 2 square, 4. 1 square, 1 square. There will be 2 there. That will be 6. 2, 4, 6. Indication for also BCC crystal structure. So I know that this system or this pattern is for BCC crystal structure. Even if I know the BCC crystal structure, I will get the plane. Why? Because no BCC crystal structure, I know that 2, 4, 6, 8, 2 will be for the first plane, 4 will be this one, 6 will be this one. Then we will find each plane that I showed to you here. So when we say BCC crystal structure, we know this. We know this information. For BCC crystal structure, the square of the Miller indices will be in a pattern like this, an even pattern, and the summation of the Miller indices as well will be even number. This is going to help us to find the planes, and if I have the planes, I can find the BCC crystal structure. A BCC crystal structure. Now, I will explain FCC in the next video. They will be short videos. Thanks for watching.